G'day folks, it's me again. Well, for tonight's little equipment inspection, we're going to have a look at some control gearboxes which I've made up. So when you want to run a high intensity discharge lamp, you need at the very least a ballast, and for some type of lamps you also need an igniter of some description, and if you really want to gild the lily you need some sort of power factor correction. So I've got loads of ballasts and loads of igniters, but when I really wanted to test a lamp I'd have to get the ballast out, I'd have to wire it all up, and it was a bit of a pain. So I decided to build some ballast boxes. So I did. So as you can see, I've built quite a few, where it's just the main flavours really. Bottom left hand we've got the 400 watt high pressure sodium or metal halide. The bottom right hand we've got 400 watt mercury vapor. There's also a toggle switch which triggers a parallel type igniter, because there are some halide lamps which are designed to run on mercury ballasts. On the middle we've got 250 watt sodium or halide. On the right 250 watt mercury vapor, that's also got a triggerable igniter. The top left we've got 175 watt constant wattage auto transformer for American style 175 watt mercury or halide lamps. Top right there's a dual tap ballast, either for 100 watt or 150 watt sodium or halide lamps. Top layer we've got some smaller ones, but they're still dual tap. On the left it's either a 50 or a 70 watt sodium or halide. On the right it's either a 50 or an 80 watt mercury vapor. So I've got really all the common wattages that I can just literally just plug and play. If I want to just get a 150 watt halide lamp, pull it out, plug it in, and off we go. Let's pull the cover off one and have a look inside, shall we? So I've took the cover off the sun gear, the 400 watt, and inside straight away you can see the big choke. It's a Philips BSN 400 L34. Those encapsulated ballasts are probably the best ballasts in the world. Going further down we've got the igniter unit. It's a Latron. It can kick out 4 to 5 kV to start the lamp. Further down we've got the power factor correction capacitor, because obviously these have got a lagging power factor, and if you've got loads of them on a circuit, the apparent power and the real power starts to become an issue. And I'll just change the angle to see the wiring. There's the way I've wired the plugs at the front panel. It's a bit messy, so don't look too closely at that, but anyway, all the covers are earthed because they are metal. And these cases, I bought them because they were cheap at the time and I like to look at them, but I really wouldn't recommend them because they are quite flimsy, but they do the purpose which I want of them. So anyway, let's see how I use them. So I've selected a 250 watt metal halide lamp. It's a GE multi-vapor lamp made in the USA. Anyway, it's designed to run off a 250 watt mercury vapor lamp, so I'm going to select the appropriate ballast. Power on. And trigger the igniter. And ignition. It'll take a few minutes for this to reach full power, as is typical with all discharge lamps. Nice hum from the ballast. They are very focus, you fuck. They do reverberate quite nicely. I might just pause this and come back when we're at full power. Right, it's been a few minutes. It's stabilised at full power. It's quite a nice light actually. It's about 20,000 lumens. CRI is 70%. The colour temperature is 3900 Kelvin. CRI is average for a quartz metal halide lamp. It's quite nice anyway. Doesn't have that overly yellow tinge that you normally get with the clear American lamps. But yeah, there we go. So I hope you found that interesting. If you haven't, then you probably haven't seen this far, so meh. Anyway, bye bye now. See you later.